In this problem, we are given this infinite series. And we've said, hey, that infinite series is f of x. And we want to find f of 1/2. Well, the only way to find an exact value is to know that somehow I have to turn this function, or this series, into an exact function. And so I'm thinking geometric. The problem is if I divide 3x squared over 2x, I get 3x over 2. But then if I divide the next term, I get 4x over 3. Well, this is not a common ratio, so it's not geometric. So I don't know what to do, because I could only sum it if it's geometric. However, integration and differentiation could also take us into something that we know exactly. So if I try to take the derivative of this, I would have n times n plus 1 times x to the n minus 1. Well, this isn't anything I know, so that doesn't help me. So now I'm going to think about integrating this series. Okay, well, if I were to integrate this series, then I would get n plus 1 times x to the n plus 1 all over n plus 1. If I cancel these out, now I really have the summation of x to the n plus 1. And this is geometric. So let's just see what would happen if I integrated all of these. So if I integrate all of these, I'm left with x squared plus x cubed plus x to the 4th plus dot dot dot. And my final is the summation from n equals something to infinity of x to the n plus 1. Well, how could I start with the right first term? Well, n would have to be 1, so that 1 plus 1 would give me that x squared. So that means that the integral of f of x is really equal to the summation from n equals 1 to infinity of x to the n plus 1. But that's geometric. When we look at the common ratio, it's going to be x every time. And so that would be the integral of this f of x is also equal to a sub 1, which is x squared, all over 1 minus r, and r is x. So this is really equal to x squared over 1 minus x. That is the integral of my f of x. So if I wanted to get back to f of x, I would have to take the derivative of what you see here. And so that means I would have to also take the derivative of what you see here. The derivative of that is going to require the quotient rule, where this is p and this is q, and our quotient rule is p prime q minus q prime p all over q squared. So I'll have 2x times 1 minus x minus the derivative of 1 minus x is going to be a negative 1 times x squared all over 1 minus x all squared. This is really what my f of x is. That is really the series that represents all of this. So if I want to find out what this is when x is a half, I just plug a half in for all of these values. 1/2 here, 1/2 here, 1/2 here, and 1/2 here. And I get 2 times 1, 1 minus 1/2 is 1/2, plus, because of these two negatives, 1/2 squared all over 1 minus 1/2 squared. As I simplify this, we have 1 plus 1/4 all over 1 minus 1/2 squared. Well, that is 5/4 over 1/4. When I copy.flop, it's actually amazingly simple. The answer is 5. But only if we thought to take an integral of what you see here, and when we did, it turned out to be something geometric that I could use to build a series. Once I built that series, then I took the derivative back to get the f I wanted. Pretty tricky, but not too tricky for you guys.